Hey guys, welcome back to my channel. My name is Archana and I am a homeschooling mom of two boys aged 8 and 3. In today's video, I'm so excited to take you guys along to do a lesson in science with us, with my 8-year-old third grader. This year, we are using the elemental science curriculum, which is divided into physics, chemistry, and biology. But this year, we are doing the physics, chemistry, earth science, and astronomy. So we are in our physics heat and heat transfer unit now. So I thought it'd be fun to take you guys along to do a lesson in science with us. So the flow of our science lessons usually goes like this. We learn the concepts first using our spine, the Usborne Science Encyclopedia. Basically, this is our spine, and it is the spine usually gives us a rundown of the concepts that we need to know for the unit, and it also has a QR code, and we watch the video relating to that particular unit, and then we conduct our science experiment, which helps us to understand the concepts better. And then there is a student workbook with a little bit of copy work and an explanation of the experiment that we just conducted, which my son usually fills out after lunch. So I hope you guys enjoy this science lesson with us. So heat is a form of energy. Right, Yashu?
Yes.
Just like electricity, heat is also a form of energy.
Yes, and there are some forms of energy like usable energy, heat energy, light energy.
Very good, right. So heat can be transferred from one place to another by three forms: conduction, convection, and radiation. These are just fancy ways to say how heat is transferred in a solid, in liquids and gases. Okay, so in a solid, for example, some things are considered to be good, some things of heat.
Good conductors.
Conductors of heat, very good.
Yes.
So if a particular substance can carry heat very efficiently from one part to the other, it is called a good conductor of heat,
Yes.
right? So when I'm cooking soup and there is a metal spoon that I forgot inside the soup pan, right?
Yes.
And you go and touch it after 10 minutes, will it be hot to touch?
Yes.
Why?
Because the heat from the soup will flow into the metal ladle and cause it to heat up, but it will also cause the soup to cool down a bit.
Okay, it could, but we are constantly providing heat to the soup, right?
Yes.
So it may not cool down the soup significantly,
Yes.
but that's a good thought, yes, because heat always moves from a hotter object to a colder object,
Yes.
right? So when I am heating something up, the source which is closest to the heat, it vibrates and it starts to dance around and it starts to spin around, right?
Yes, and you remember those times when I heat up metal utensils in candle flames?
Yes, and what happens to the part that's closest to the flame?
It gets hotter and its molecules move around, and the space between those molecules gets bigger, and it causes the whole object to get bigger.
Yes, it's almost like the part which is closest to the heat starts to get this energy and starts to dance around, and then the one next to it,
Yes.
it sort of becomes infectious,
Yes.
and the molecule next to it starts to dance around, and soon the entire object is dancing around because of the heat. Can you tell me something that does not conduct electricity as quickly, where the electrons are not free floating,
Plastic. Plastic
Okay.
is an insulator, an object that does
Very good.
a material that does not conduct electricity easily
Is
and
called an?
insulator, and it has very high resistance to the flow of electricity or heat.
Okay. Can you think of something else that's a good insulator?
Rubber,
Very good. Anything else?
wood.
Wood.
CONDUCION.
Yeah, but
CTION.
Very good. Conduction. Now we're moving to convection. Do you know anything about convection before we move on to this? Anything
Yes,
at all?
convection can be used for when something seeps down in a sea of something, gains heat, then comes out hot. Maybe?
Maybe. Okay, let's move it. Now, the same thing, we learned about heat transfer in solids, right? That's
Yes.
called conduction. Heat transfer in liquids and gases is called convection. That's it. When a liquid or a gas is heated, the part which is nearest to the heat source expands and becomes less dense. So it rises. Now, we saw that in a solid, the part which is closest to the heat, what happens to the atoms? Yashu?
What happens?
They start vibrating and dancing and dancing.
and
Now in liquids and gases, you know what happens?
Yes.
The part which is closest to the heat
Yes.
starts to become less dense. And almost whimsically, they start to rise up higher. They become less dense and they start to float
The
up.
sovereign and kingly molecules.
The molecules start to float up,
The
right?
sovereign and kingly.
So this is why when we turn on the heat in the winter, the rooms in the top floor get warmer than the rooms in the bottom floor,
Yes.
right? Why? Because hot air,
Because hot air rises and it leaves behind cool air.
which is cold air is denser, so it's heavier than hot air, right?
Yes.
The last type of heat transfer is called
Radiation
radiation. Is the only one which can even travel
in space.
yes, or vacuum. The
Two.
sun sends out infrared radiation, as do hot objects such as fires and light bulbs.
But I have a question for you. But how does
You can look at me. You don't have to keep.
But how come but what will happen if infrared radiation is not what if will happen if infrared radiation is kept calm in one place and doesn't float out?
It doesn't matter, right? So we just read that infrared radiation is not dependent on particles to carry it through, right?
Yes.
It can even travel in vacuum.
Yes.
Now the sun is so many light years away from us.
It's not many light years, just 93 million kilometers or 1 AU.
Or one
A astronomical
unit. Okay, fine.
Yes,
alright.
and 1 light year equals to 42,868 astronomical units.
So it is light years. I was right. So there are light years involved. Right.
9.461 trillion kilometers.
Okay, what I'm trying to say is the sun's energy travels through space, isn't it?
Yes.
Is there a continuous source or stream of air to transfer that energy to the earth?
No.
So, exactly. Dark colored objects absorb radiation while light ones reflect it and stay cool. Now, what did we learn from our pizza box experiment? Why did we paste the bottom of the experiment?
I want to talk.
Why did we paste the bottom of the pizza box with black instead of white?
Black absorbs 100% of all light that hits it into heat. And it's true because...
And black also radiates heat.
Yes.
Right? So now that we've finished reading the concepts and watching the videos, we're moving on to our experiments. This is my son's favorite part. Okay, so we're moving on to our heat transfer experiments. Are you ready?
I'm ready.
Okay. So I want you to put your hands on the two bowls on either side of the brown bowl.
Okay.
So, yeah. Exactly. So how does this hand feel?
It feels hot.
And the other one in the white bowl?
Feels cold.
Very cold. Okay. Now, so I want you to now gently remove your hands and put them both in the brown bowl.
Okay. Now, the hand that was in the hot water is beginning to feeling cold, and the one in the cold water is beginning to feeling hot.
Okay. So this was hot water.
Yes.
The extreme right side one, that one was cold water, and the middle one is room temperature water.
Yes.
Right? So what happened when you placed your hand? Okay, now place your hand in this hot water. Hot water, okay. Now put it in the room temperature water.
Okay.
So what is happening here, Yeshu?
It's getting cold.
Why?
It's getting cold because the coldness from here is flowing into here, and heat from here is draining into here.
Okay, so heat from your hand is draining into the cold, right?
Yes.
So now put your hand in the cold, ice cold water on
This
the left.
hand?
Yes. Okay, put your hand in, put your hand in the ice cold water
Okay.
and put it in the room temperature water.
Okay.
How does your hand feel?
It's getting hot.
Why?
Because heat from the regular temperature water is flowing into my hand.
Okay, Yeshu, see, on the floor,
Yes.
you have a piece of
Carpet.
and
Some
a piece
aluminum
of
foil.
aluminum foil. Now, I want you to place one leg on the carpet and the other leg on the aluminum foil and tell me how you feel.
The carpet is feeling warm and the aluminum foil is feeling cold.
Why? What is happening?
what is happening? This one,
Why does the aluminum foil feel cold?
it's a good conductor of heat. That
Okay.
means it doesn't let heat stay inside.
Alright, so the heat is flowing from your body to the foil,
To
right?
the foil.
And what about the carpet?
The heat from the carpet is flowing into my foot and making it hotter.
Okay. So in winter, if you were to build a house, would you cover your house in carpet or in aluminum foil?
Carpets.
Why?
Because carpets would make the house warmer.
Okay, because are they good conductors or bad conductors?
Bad conductors and good insulators of heat and electricity.
So I hope you enjoyed the science lesson with us. And if you did, don't forget to subscribe and give me a thumbs up. And I'll see you in another video really soon. Bye-bye.